Hello everybody, this is Mr. Gilmore. Alright, I'm going to walk you through how to use this PhET program. We've used these simulations before from the University of Colorado. When you click on the link in Unit 8 that you're seeing this video in, that will take you into this game. We were talking earlier this week about how to balance chemical equations. There, at the very end of the video that I sent out to you guys, we talked about the law of conservation of matter. And that basically means that when you're doing chemistry, all you're doing is you're rearranging the elements that you're using in those chemical equations. You're not creating brand new elements. So you're not going to mix hydrogen and helium together in a chemical reaction and get iron. That would be alchemy. And that's not something we're able to do in chemistry. So you have to have the same number of elements on the left-hand side of the equation that you also have on the right-hand side of the equation. You can't have a mismatch, so you couldn't have 3 hydrogen on the left and 5 hydrogen on the right, because then you would ask, well, where did those 2 extra hydrogen come from? So balancing equations is the first time we're going to kind of do a little bit of math, but it's the practice of trying to make sure that you get both sides of the equation the same. So if you guys remember, when we look at a chemical equation, right, so if we look at the letter N here, that's going to be our atomic symbol for nitrogen. The lowercase or the subscript 2 that you see to the right of the N, that tells you how many of those nitrogen atoms are in that single molecule. And then what we're going to be changing is the coefficient, which is the number to the left of the compound that you're looking at. This tells you how many of those molecules you need in what ratio in order to make the reaction work. Those of you that are familiar with cooking, right, this is basically a recipe for how to cook something. So you could say like this much butter and this much dough is going to give you this kind of bread, right? So you have your ingredients, you have your reactants, and on the right hand side you have your products. Just like with cooking and baking, right, if you start with 5 pounds of ingredients, you're not going to make 10 pounds of product. The matter is just going to rearrange, it's going to change itself, but you're not making anything brand new. So it needs to be the same on both sides. Although in cooking you're usually evaporating something, so you usually lose a little bit of weight just as you're losing moisture in whatever it is you're cooking. So if we look at this chemical equation, the first step when you're trying to balance these for yourself is let's set everything to 1. So I'm going to push the arrow up for each of these and set each one to 1. And we can look in each box and count the number and type of circles that we see, or spheres, to see if they're the same. So on the left hand side I see 2 blue and I see 2 white. On the right hand side I see 1 blue and 3 white. So they are not balanced in either the blue or white, either the nitrogen or the hydrogen. So I'm going to keep on increasing these, or keep on changing this until I get it the same on both sides. Well, one way that you can know for sure how to get it right is you just think, okay, well, when does 2 and 3 match up? Some of you guys that are familiar with multiplication, if I were to factor that out, right, the closest I'm going to get is 2 times 3, or 6 on one side and 3 on the other. So I'm going to bump this up to, oops, now we have 6 white. Do you see that once I increase that, we're at 6 white and 2 blue? Okay, so I increased the product to 2, and now on this side we have 2 blue and 6 white. Well, those are both even numbers, so we can work with that. So I already have 2 blue over here, so I don't need to change the blue, but I need to get up to 6 white, so I'm going to change the hydrogen to 3. Look, I got a smiley face. Yay! Alright, so that's how you know that you've done it, right? Once you've balanced the equation, so this chemical equation, the ratio or the recipe would be 1 nitrogen molecule plus 3 hydrogen molecules is going to give you 2 ammonia molecules. Okay, nitrogen plus hydrogen gives you ammonia, or NH3. Alright, let's try another one. Okay, another common chemical reaction. What if we do a chemical reaction where we separate water into its component parts? How much hydrogen, how much oxygen would you make for every water molecule? Alright, so just like before, I'm going to set each one to 1. Okay, and then we can look at both sides, the box on the left and the box on the right. I see No, we're not even. I see 1 red, 2 white, and 2 white and 2 red. Okay, so if we set this to 2, now I have 2 red, 2 red, 2 white, or 4 white, sorry. And so to get this to 4, so for every 2 water molecules that you chemically react, if you use electrolysis, you're going to produce twice as much hydrogen as you do oxygen. Okay, you get 2 hydrogen molecules for every 1 oxygen molecule, although oxygen is heavier than hydrogen. Alright, let's try a third example. Okay, this one's a lot harder. So you can see it's stepped up. We've got a lot of things to keep track of. Luckily, this application, you don't have to write all this down. If we were doing this on paper, you'd have to keep track of all your different elements. But since we're doing this visually, we don't have to write anything. So we're just going to be moving that arrow up and down. Okay, so I see 2 red, I see 3 red, I see 1 gray, and 4 white. So right now I know I'm going to have an even number of oxygen. There we go. So if I have 4 oxygen, 4 red, 4 oxygen, 2 white, 2 white, that gives me 4 white over here, and 1 gray, 1 gray. Alright, so I just had to increase my oxygen and my hydrogen to get this one balanced. Alright, so what you guys are going to do, that's the introduction, what you guys are going to do is play the game, and I want to see how far you can get. Okay, level 1 starts off pretty easy, level 3 the molecules are more complicated. So, and now we're dealing with more than just like maybe 3 sets. So let's do an example of one of the harder ones. So I'm going to set each one to 3. Or I'm sorry, to 1. So we see what we're starting with. Alright, so I see 2 blue, 1 blue, 2 and 3. Okay, so I'll need at least that to equal the oxygen. Alright, now I'm at 4. Okay, that gives me 6. That gives me an even number. Let's go. Okay, so that's 2, 4, 6, 8, 6. Whew, no, that still doesn't work. Alright, let's move that up. This is going to have to go up to 4. Alright, so 3 times 4 is 12. Get that to 6. Alright, so I think I've got it now. Okay, so I've got 4 blue, 4 blue. I have 3 times 4 is 12 white. 2 times 6 is also 12 white. 6 red, 6 red. Okay. So could I reduce it any further? Just like with multiplication, could I reduce this down? No, actually, because I can't divide 3 by a number and get the same ratio. So this should be the best ratio. So let's check it. Yay, it's balanced, plus 2 points. Ding. Alright guys, so that's what I want you to do. That's what I want you to do on Friday the 23rd when you should be going through this. This is not for a grade, but this is a skill you will have to have for the test. And I will talk to you guys more about it whenever I see you back in class on the 26th and 27th. That's when I'll be back and able to teach again. So that week that I come back, we'll work on balancing equations again. Thank you very much, everybody. I will see you guys when I get back.